Yeah, boys, back, mate. I was just saying rotate device. On the bloody phone, YouTube. What is this? Hold up. You don't need this in vertical now, do you? You want it in horizontal, YouTube. Stop playing around. Stop playing around, YouTube. What is this? Keeps telling me rotate the device when I'm trying to have it in landscape, so it doesn't look like I'm bloody writing on papyrus paper from Egypt. I'm trying to make a video. Are you kidding me? What is this nonsense? Hold on. I can fix this. A disaster. Won't even let me rotate it. What is this? Well, I guess it'll be in this mode then. I wanted it in landscape for the record, but it wouldn't let me do it. So anyways, right now I'm pretty much talking to the future viewers, you know, because there's really nobody in here now. But listen, YouTube, we got the reactor running. It hasn't blown up. What can I say? It's time for celebration, right? What does that mean? That means more work for me, but I don't mind. You know, let me tell you what we're gonna do, right? What we're gonna do is, I want to build a new distiller. I want to build two things actually. I want to build a new distiller, and I also want to build a gasifier. Now, this distiller, let's talk about that. Now, this distiller, I want this to be like type of distillers they use in oil refineries, right? Like, I want a distiller. I just turn it on, it's hands off, and I could just walk away, and they'll separate all the fractions for me, right? Just like they do in the oil refinery, you know? Column fractional distillation column, yeah. So that's what I want to build. It will be quite the build because it has to be really big, you know. You got to make it big, and then you got to have either these distillation plates, like bubble plates or bubble caps, or you have to have, what do you call it? You have to have the, there's this packing material they use in there, which kind of like, it increases the surface area of the gas by maximum. So it will be quite the engineering thing to build, kind of DIY, but that's what I need because, you know, for me to get this to the next level, you know, now we're getting the large quantities of the oil and the gas. I gotta have a way to distill it in a large quantity as well, and what I have now is not gonna really work for that. And I also want to build a gasifier, because that will then allow me to use the coal products I get from the pyrolysis, kind of recover the energy of that in some way, you know, so I can use that to heat up something else, right? Who knows? But that also does remind me, in the next distiller I build, it's going to be like kind of like a trifecta distiller. So I'll be able to run it off of the coal, I'll be able to run it off of the gas or the oil. So I want like a waste oil burner in there, I want it to be a coal furnace, and I want it to also be able to use the actual pyrolysis gas itself. Because with that being said, if I can do all three, then I can really use anything I want to run the distiller, right? So that would be a good thing for that. And once again, for the gasifier, I'll be able to use the coal, I guess any oil as well in that, right? Really any solid products to go in the gasifier. And so those are the two things I want to build. And another thing I want to do with the reactor itself is I want to make the motor kind of like how washing machine motors work, right? Like it's kind of like automated, right? Where it's like, you know, washing machines, they turn on, it turns off, and it kind of like goes forward, it goes backwards, like all on its own, right? Like you don't gotta touch anything. That's what I want for this motor, because right now, I gotta turn this motor forward, I gotta turn it reverse for however long I want it, but obviously, that's not really that sustainable long term. So I actually been speaking with this cool, really cool dude. He's from Canada. You know who you are, mate. He's been helping me out. You know, a lot of people say like, oh, you need to use a little Arduino, right, to make the motor automatic. And he was telling me, in industry, they don't use Arduinos. They use like physical things like contactors and timer delays and stuff to make the motors do what they do automatically, right? So that's what I'm gonna use. I'm gonna use these little contactors and all that type of stuff. It is kind of expensive, I won't lie. It's a lot more expensive than our Arduino, but it is like physical and malleable. You know, it's kind of like fiat versus gold currency. What's better? Gold is always better than fiat, right? But fiat can work, but only for so long. The gold works forever. So that's what it is like. It's a long-term solution. So that's what I'm gonna do. Probably like between next month or the month after that, because it is kind of expensive, I won't lie. It's like It's like almost $600 worth of electronic parts, right? Like, that's kind of expensive, man. I won't bloody lie. You know, I might have to take out some credit for that to get that. I mean, yeah. So I mean, like, that's it with that. You know, in terms of what I want to build, the additions. Oh no, I know one more. I want to build one more thing, right? I want to make this thing have an automatic feed in it, right? Where I can feed in plastic while it's running, because it gets very hot, and it's a waste of energy for this thing to cool down just to add more plastic in, right? Because obviously, if I open that lid up when it's like 800 degrees, I believe it's gonna get blasted with a face full of pyrolysis gas, oils condensing up in my freaking lungs and crap. So that's not gonna do. I need to make like a hopper, an airtight hopper. I can put plastic in and like close it, and then like open it, and plastic falls in, and then like close it. I don't know, like you know, it'll make sense. I guess a lot of engineering stuff, real talk. You know, we're doing like mechanical engineering, electronic engineering, radio engineering. I mean, it's not every type of blade engineering under the sea that we're doing over here, in it. So it is quite a lot, but you know, at an industrial scale, once again, this absolutely has to be continuous. Like, not doubts, right? It has to be continuous because it's so much more efficient. You know, and I noticed that because, you know, I get this thing up to 800 degrees, right? And once it gets up to like the max temperature it can get, I can turn off some of the magnetrons. Like I have 3 on, right? But I could leave on just like 2 or even 1, and it'll really stay at that temperature, right? So obviously, when the hotter the plastic gets, or whatever we put in there, the hotter it gets, the better it absorbs the microwaves. So it's a waste of energy for this thing to be cooled down all the way down to like 100 degrees Fahrenheit, we're talking here. Just for me to, you know, have to load more stuff in. Let me load the stuff in while it's hot, right? And then, you know, that stuff while it's hot, it'll go in there and it'll become hot because it'll take the hot energy from it. And then now everything will absorb microwaves better from the get-go, right? From the get. So that's the goal we want to do, really, with this. So those are like 3 things, I guess. And I mean, like, once I really have those 3 main things, the distiller, the automatic motor, and then the continuous feed, right? When I have all those 3 things in there, you know what I mean? Like, at that point, I guess the only thing I have to do after that is like a continuous discharge to get the carbon out. But frankly, I think this reactor, this design won't work for that because it's kind of, the body isn't long enough on it, right? So, like, if I had some type of way to, where the carbon will come out, like at the very end, you know, some plastic would also come out because the blades, like, just a couple rotations of the blade move the plastic to the very end. So we need a much larger, longer reactor. But, you know, once I can get some things down, right, like the motor and the continuous feed, then it'll be pretty easy to build another one of these just way longer, right? It'll be pretty easy to do that and then just have a discharge at the very end. I mean, that's kind of like intuitive. It'd be quite easy to do. So I'm not really worried about that, right? The main thing I'm worried about is just, you know, doing that, being able to feed in plastic in the middle of it running. See if anybody's saying anything, because YouTube's not showing me anything. Oh! What's up, Mr. Carbon Master? Can the Mark IV turn grass into car engine oil? I don't know about grass. I don't know about grass. You know, like, the reason why we turn plastic into diesel and all that is because plastic has those compounds in it already. Plastic is like crude oil. I mean, so it's just like how we turn crude oil into diesel. We're doing the same with plastic, but grass does not have those compounds. But we can turn grass into the so-called natural gas that we make, you know, without a doubt. I've done it before. Where'd the chat go, YouTube? Oh, here we are. You've been following this for a while, D-Tip 1979. Well, hey, it's good to see you, man. 2 airlocks and slower agitation. Christian, yes. It will need to be 2 airlocks ultimately. Slower agitation, yeah. Slower but continuous agitation. That's the key, you know. Because if the agitation is too slow, then the way how I have the motor set up, it kind of like the motor won't be able to run if it's like at such a low voltage, right? It has to be like at a minimum speed. But like, I feel like the ultimate goal is it just needs to be longer if we're talking about true continuous stuff here, you know. But you know what, I will say though, as a batch reactor, if we're just talking batch wise, this reactor is actually really cool. Like, it actually works really well if we're talking just batch wise, because You know, yes, it does consume quite a bit of electricity, I won't lie. But here's the thing, guys. We actually get quite a bit of electricity, well, not electricity, but energy out, you could say. Like, so let's say, so average run of this thing is about 22 kilowatt hours, between 22 25 kilowatt hours. Well, if you add or sum up all of the products we get, the coal, the gas, and the oil, you get about 20 kilowatt hours out. Now, of course, to convert that into actual electricity, you probably only get like 10, but it's still there, right? And that's with a very inefficient batch scale, you know what I'm saying? So, like, there's only, you can only go up from here, right? I hope you blow up. This would be beneficial and make gas prices cheaper. It would. It would. You know a guy from Texas who is helping some of the big companies do this. You're onto something. I think this in Nigeria, I think it's in Niagara, would be amazing. Yes, exactly. We're gonna put this everywhere, guys. Like, I'm telling you now, you know, mark my word. Once this really gets somewhere, right? Like, once I really get this thing done, it's gonna be all over the world, straight up. Like, every country, every city, every province, it's gonna have one of these. And as long as it's running off of solar or wind, your electricity bill is free. The distillation runs off of the byproducts of it, so literally the cost of making the gasoline will literally only be as much as the cost of, like, transporting everything in. So some people ask me, like, what's the total electricity bill? And for a month, right? For me to run this thing every day for 5 hours, including the shredder, including the compressors to compress the gas, it cost me about $100 a month. Now, if you ask me, I'm getting more than $100 worth of value out of this thing to get rid of the trash, to make these products, to turn electricity into liquid, storable fuel, stable fuel. I think I'm getting more than $100 worth out of it. You know what I'm saying? You know, I don't mind paying $100 a month to run this thing. It's a good deal to me, right? Where's the chat go, mate? Why does YouTube just make the chat disappear? Here we are. Derek Tippins. I'm not sure who Derek Tippins is a dude in here. Oh, yeah. Yeah, turning plastic back into oil is the key, because it's kind of stupid when you think about it. Why it's just not normal, you know? You know, like, we recycle metal like a no-brainer. Like, oh, that's metal. We can turn it back into base metal. Okay, that's plastic. Let's turn plastic back into base plastic. Does turning scrap iron back into new iron, does that consume electricity? Yes. Does it consume more energy than you get out? Yes. But is it monetarily profitable? Yes. And that's the exact same thing I'm proposing with this. Yes, it will always take more energy than the energy we put in. That's just bloody science. But monetary-wise, profit-wise, I think this is a done deal. I mean, think about the mechanical recycling industry. The mechanical recycling is worth $100 billion a year, and they don't even recycle squat, right? $100 billion a year, or something like that. Maybe not 100. Maybe that's a little bit too much. Maybe, like, what was it, like like 10 billion. But they're worth a lot every year, and they don't even really recycle. But do they get more energy out they put in? No. They're at an absolute loss of energy. They have to ship it across the world, recycle it in their big plants, clean it and all that, then ship it all the way back and make a new product with it, all this mess. So they're at an absolute loss of energy, but they're at a gain of profit still, clearly. So this will easily be profitable. Just by the fact that we're turning plastic into an environmentally friendly thing alone, right? We're turning it into a form that is not polluting. Well, I mean, like, of course, burning the oil and all that's polluting. But you know what I'm saying? Like, it's not like microplastics. It's not in the ocean. It's not something that sea animals can choke on and get caught up in, right? You know what I'm saying? Like, we're changing it into a way more useful form. Just by that alone, the waste management part of it, that's profit right there. If you ask me, pure profits. We are talking to a company. Use this in the islands and use it for fuel for ships. Yeah, the fuel from this. I'm sure that ship engines could use just the raw fuel from this. The raw. It doesn't even need to be distilled. Just needs the water separated. What's up, Squid G Sailor? Wait, Squid. I always like, I can pronounce your head in my name. I mean, I can pronounce your name in my head, but then I can't say it out loud for some reason. Like Squid G Sailor. You're a part of a company that is doing this in Nigeria. Yeah, you're in Georgia. That's cool. So you're saying Nigeria is the move. I hear you with that. Mr. Carbon Master. I do like your name, Mr. Carbon Master. Our military would love this. Time for some yoga ball jokes. Yeah, mate. Hey, I got a yoga ball right here, matter of fact. Wait a minute. Look, I got one back here filling up. You see that? It's filling up. So I got the reactor running right now. There's packing peanuts. Or like, you know, little styrofoam peanuts. That's what's in there. Got one of my balls filling up right now, mate. You love to see it. You love to see it. You get to see my balls live, my friends. In fact, I have 3 balls down there. Right behind, well, in front of me, rather. They're down there. That reminds me, another major part of this is I need to find a better way, not even really to store it. I mean, the yoga balls work, they're fine, but to compress it, you know what I'm saying? Because I've been using these scrap compressors, but they only go up so much, you know what I'm saying? Like, I need to either invest or build a real compressor, you know what I'm saying? Because you compress natural gas up to like 3,000 psi. Now, I'm not going to compress anything to 3,000 psi in my freaking backyard, mate. I'll tell you that much, right? But, you know, at least let me compress it to like maybe 300, 500, you know what I'm saying? How did I come up with the yoga balls for storage? Well, it actually started with using gasometers, which is like kind of a form of like you have 2 sliding cylinders, one is filled with water. So that was the first thing, because I saw this dude, Nighthawk Can Light, on YouTube, make gasometers for storing his hydrogen he would make. I started to do that, but the capacity was trash. It worked, but very low capacity. So after that, I saw this other dude on YouTube, this other bloke, right? He was making biogas, and he was storing it in trash bags. He modified trash bags to have a little adapter in it he could screw in and hook up a barb to. I did that, but then I kept having leaks of my trash bags. Like, it just kept leaking. No matter what I would do, I duct tape everything, it just always leaks. So then after that, I was about to use beach balls, but I wanted to start smaller, so I started using balloons. In fact, if you go back to some of my really old videos, you can see I used to store this gas in balloons, like the biggest white balloons I could find. Like, they would get like this big, like as big as my head, right, a little bit bigger. But after that, I was like, okay, that's kind of bad too, because it's like kind of trash. So then after that, I was like, okay, well, let's use, like I said, I was going to do beach balls, but then I started at inner tubes, right? Like those little things they use in tires. And those worked a lot better. Those worked a lot better than inner tubes. But then I was, one day, I had an inner tube filled up, right? I walked away, or I had it on the reactor. I walked away for like 10 minutes, and I came back. And the reactor was like shooting out pressure because the inner tube was completely full. And I'm like, alright, they have Brexit capacity as well. We need something even bigger. So then I just walked inside my mom's little exercise room, and I saw the exercise balls, and I was like, oh, the sacred geometry of the universe. Balls. I was missing out this whole time. So then I was like, okay, well, how can I get a valve into a yoga ball? It was actually quite simple. You literally just, like, put a barb on the end of the valve, and you could just force it in and jam it in the nut, right? Anyways, that's enough talk about balls. Let me see what you guys are saying. Where'd the chat go, YouTube? I can't see it. What the heck? Wait, somebody type something so the chat pops back up. Because it disappeared and I can't get it back for some reason. What is this? This is nonsense, man. Why does YouTube do this? Oh, there it is. Okay. Wait a minute. Where's everybody else? All I see is the message you just sent now. It won't show me anybody else's messages. Oh, here we are. I swear, man, this is tripping. This is tripping. What's the ideal pressure for storage? I would say around 2,000 psi, just like they do for natural gas. 2,000, 3,000 psi, that's the ideal pressure. Because this gas we make is pretty similar to natural gas, if you ask me. It has a lot of the same properties. Burns kind of the same stoichiometric ratio. Where am I from? I'm from Georgia. U.S., Georgia. What are your plans to improve the efficiency in order to break even on the energy cost? Yeah, I was just talking about it earlier, mate. In order to improve efficiency, what we want to do is we want to make this a continuous feed reactor. You know, it gets very hot, but all that heat energy is kind of lost every time we gotta turn it off and wait for it to completely cool down, just to load more plastic in. So making a continuous feed is the best way to improve efficiency immediately. And then the next thing is experimentation, like finding the best ratio of catalyst, finding the best ratio of blah, 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 the capacity, all that type of stuff. Because something I did notice is, you know, I will put in, like, let's say I put in a pound of styrofoam, right? It would get up to 800 degrees. I put in 23 pounds of coal, gets up to 800 degrees, right? But obviously, a pound of styrofoam is a lot less actual stuff than that coal. So, like, there needs to be, like, we need to get the perfect balance of how much do you feed in at one time, how much goes in there, how many magnetrons are on, you know, and making things continuous, making things, like, computer-based, so it's like, okay, like, maybe not all 3 magnetrons need to be on the whole time. Maybe only, like, the first 2 need to be on, and then when the plastic reaches the very end, then the last one turns on. You know, there's so many ways. There are so many ways we can improve the efficiency. I really don't even, like, I'm not even bothered about it, right? The electricity costs, because we have so many ways to improve it, real talk. You have a friend in Corpus Christi, Texas. He has a machine that can take different types of what? Take different types of that. Wait, you say different types of that. Put them into a wind tunnel. They come out. It's 5 micron size. You don't have to separate it at all. I don't know what you're talking about. You talk about different types of plastic. How much energy is your system using when all 3 magnetrons are switched on? It consumes 4,800 watts. So I mean, of course, it depends on how long you run it, right? When I run it for 5 hours, it's 22 kilowatt hours, which is around just under $3 in my area, right? You're in South Georgia. That's cool, yeah, mate. And maybe we really can meet Derek, because you know there's some other people that are going to be coming by Atlanta and want to see this thing in person. You know, to me, some people like they tell me like, dude, if this really works, it's amazing. And to me, I'm like, if this really works, you know what I'm saying? Because to me, it's like it never was a matter of it does it really work, because it's real science. It's a matter of how good does it work. You know what I'm saying? How good does this machine work? Not if it really works. There's a lot of people, like investors, are like, we need proof that it works. I'm like, to me, what more proof can I offer? Right? You know what I'm saying? Oh wow, so you're actually quite a bit away from Atlanta then. If you're an hour away by plane, you're quite far. I'm in Douglasville. Do I use cold plasma? No, the microwaves or the magnetrons use the exact opposite of cold plasma, my friend. They use hot-ass plasma, very hot. We're putting it in at 90 psi. PSI can store in spray cans, make a huge difference in volume. Spray cans? What do you mean by spray cans? Because right now, I store all of my gas at 100 psi, because that's the max it can go, right? I have it in 3 different modified propane tanks at 100 psi each, right? So, I mean, like, that's 300 psi total, with quite a bit of volume. So that does give me quite a bit to store, but, like, right now, I am already at a surplus of the gas. Like, I have all of my tanks completely full, and I still have, look, this ball's almost done filling up, and I already have 3 balls down there, and I have nothing to do with them. So I actually am running the distiller right now. I have like, what do you call it? I have 3/4 of a gallon of pyrolysis oil in the distiller, and we're running it for a video, because I want to see, how much, blah 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 I get out, how much diesel, kerosene, gasoline. I wanted to wait until I had a whole gallon of this stuff, but I couldn't wait because I was running out of space. Because I don't have any more yoga balls that can be compressed. I have no more space in my compressors to actually put all this pyrolysis gas. So that definitely is a huge thing in industry. Can you guys believe that there's some plants, there's some pyrolysis plants that just flare off all the gas? I can't believe that. What a waste of energy. They just flare off the gas and just get the oil. So I need to be careful with meeting strangers. You're right, you're right. What is the energy consumption in kilowatt hour per kilogram of plastic decomposed? I don't know that because, like I said, I could put 23 pounds of plastic in there, or I could put 1 pound, and then it seems to take around the same amount of time. So it's like, well, if that's the case, we want to put as much in as we can, right? I want to put in like as many pounds of plastic as we can, since it takes the same amount of time no matter what, it seems, right? I don't really know. We're still learning this thing. I mean, we just finally got it built up. Why not just 50 gallon drums for what? To store the gas in? I would never store the gas in 55-gallon drums. What product would you get if you toss a big slab of raw beef in? I want to know that too, mate. We did do sugars and starches because I had an episode where I did food waste, like potato chips. I put some cake and stuff in there. You get a lot of gas out, but then you get like, instead of getting like a hydrocarbon oil, you get like a sludge. It's disgusting. So, in fact, I still have that sludgy product somewhere. I said, do not open until 22, 22, 22, 22. You know, so that way not only now, but all the generations in the future are safe. Because that thing was absolutely disgusting. They wouldn't even burn. It was like water mixed with some oils and fats and stuff. But I do wonder what happens if we just put meat in there. So I'm going to do that. I'm going to do that one day. Let's put some meat in there. What happens if you just put crystal sugar? Yes, I want to do that too. Hey, take care, Derek. Take care, man. Thank you for stopping by. Do I know or read about Carbon Engineering Ltd, a British Columbia pre-market company transferring carbon into usable energy by sucking in carbon from the air. What you're doing is great as well. I have not heard of that. All I heard about was when they take the big thing, suck CO2 out the air, and make just carbon out of it, right? I heard about that. Distill the sludge. Yeah, I probably should, just to see what happens. Does the pyrolysis gas liquefy like propane or butane? It doesn't remain a gas under pressure like methane. I don't know, because I don't get it under high enough pressure, but most likely it does not liquefy. Most likely. Hey, see you later, Squidgy Seller. Take care, man. Thank you for stopping by. Yeah, thank you for stopping by. Thank everybody for stopping by, matter of fact. You know what I'm saying? Really just came on here, chill out. You guys say I need Secret Service. No, let me tell you guys the goal. The goal is, I want to make a gallon of diesel out of this machine for less than a gallon of diesel at the pump. I know you see the videos and you see the price, you're like, how on earth are you going to do that, Jab? Well, let me tell you, there are a lot of ways to increase the oil yield that I'm not even doing yet. Primary thing is mixing the plastic with motor oil. I have not done a run with that yet, and that increases the oil yield by a ton. So I reckon that we're going to get a gallon of diesel out of this thing for less than the gallon of diesel from the pump relatively soon. I smelled something. I thought the reactor was leaking for a second. Alright, see you later, Max Smith. See you later, mate. Yeah, but we're gonna get a gallon. That's the goal, alright? I don't even care about energy, alright? Forget about energy. I care about monetary. Business. And I want a gallon out for less. Because like I told you guys, the average run is $3 of electricity. So if I can get a gallon in the time it takes for one run, then we're good, right? Is that yoga ball full? It's almost there. It's almost full. Propane will liquefy at 100 psi if you put your gas cylinder in a freezer. Have you tried? I don't have a freezer I can put my gas cylinder in. What the heck do you think I am? A freaking murderer with a big freezer where you put cows and stuff in? They got a big ass freezer like that. What do you think would be the cheapest fuel, disconsidering waste/free fuels? What do you mean by the cheapest fuel? Like the cheapest fuel would be plastic if this thing is run off of solar panels. Hydrocracking the gas to increase oil yields or any kind of cracking. No, I'm not. I currently am not cracking it because you know that is some more engineering, chemical engineering stuff that I currently have to do more research for. Yeah, this would clean up the oceans. What's up, Antonio from Tennessee? Hey, man, I was born in Tennessee. Representing, mate. Representing the good old cities. I'm from Chattanooga. Yeah, that's really the main incentive. Because I mean, think about it. If you're getting even close to a gallon out for the same price, or maybe a little bit more, a little bit less than the price of a gallon, but you're also cleaning up the oceans. What can you say, mate? That's pretty good. You thought I had a PhD in chemistry. No, I didn't even go to college, mate. You mentioned a catalyst. Is this recycled carbon from previous batch? Yeah, every time the carbon catalyst I use is always from the previous batch. It's always carbon. No, I don't have a master's or a PhD in chemistry. Even if I somehow did go to college, I wouldn't even be able to because I'm 19. So what? You have to be at least like 22 or something before you can get a PhD. What books do we start with? I don't know any books, but I have a lot of research papers that I could link to my Discord server. Coal is the cheapest fossil fuel by far. Yeah, I would agree with that. I would agree. Because coal is really just carbon when you think about it, right? I really didn't know what your question was. Asking what's the cheapest. I'm gonna check this reactor because I smell something. I don't want it to be leaking. If it is leaking, I'll turn it off. Right? No big deal. I think I hear the distiller. I think that's what it is. I hear I smell the distiller. Let me see. Yeah, it was the distiller because the flame under gone out. So I'm just smelling the pyrolysis gas just coming out unburnt. I knew I was smelling something. Let me turn this flame back on. There we go. Alright. Just had to make sure nothing was about to blow up on Livestream, right? Happy Saturday to you too, Glassmith. Alright. I got kind of behind on all these comments here. Some of the most successful smart people didn't go to college. Doesn't prove intelligence. Yeah, I agree. You know, honestly, I'm not gonna spend all that much time in college when I could just be spending time on this. That's all. That's how I see it. Or all that money, because there was a college that reached out to me, wanted me to go, but they wanted me to pay $30,000 a year for everything. $30,000 a year. Imagine if I spent $30,000 a year on this. That's all I'm saying. I can't do that. I'm sorry. What are your plans for the recovered carbon powder? I want to make a gasifier to potentially recover it that way, or get the energy out of it that way. And I also I will be making another distiller, a new design that will be a trifecta. It will run off of waste oil, it will run off of the gas that we get, and also it will run off of the carbon or the coal we get. So that's what I want to do for the waste carbon. And then, of course, it can be used as a fertilizer. But me personally, before I ever do that, I got a lot of stuff to do to make sure that it doesn't have heavy metals in it or microplastics. So right now, I literally just store it in buckets for now. And when I think about it, that's crazy because I have like 3 buckets full of it. But I've put in so much plastic. You look like I'm on vacation. Yeah, mate. You know, I pretty much am, right? When you become a billionaire, you can have chemical engineers on your payroll. Yeah, exactly. A trillionaire, rather, mate. Get it right. I'm just playing with you. Well, I'm not just playing with you. This is a $1 trillion industry, real talk. I mean, when I get this to a point where it literally is making diesel for less than it is from the pump, out of plastic waste. You know, but then another thing is, like, does having plastic waste does matter too. Like, we did LDPE. It made more kind of like gasoline-esque fractions. But then when we did styrofoam, or was it styrofoam? Was it like more like rubber? We do like rubber or tires or nitrile gloves and all that. It makes more diesel-like fractions. So it really depends so much on what you put in there. But if you're distilling it, it doesn't matter because no matter what you get out of the oil, if you distill it, you can get what you want out of it. Yes, indeed, the trillionaire crew, my friends. Trillionaire crew, indeed. I mean, truth be told, this is like the best solution for the whole car issue. Because, you know, they always talk about, we got electric cars, electric this, electric that. So that way they're not polluting. But if you're having a car, your standard gasoline car run off of waste that would have otherwise gone into the ocean, right? It's like, well, that's like the best of both worlds. We're using electricity to turn that waste, renewable electricity rather, to turn that waste into something that can be used for your car, instead of having to mine it from the earth. So, I mean, it sounds like a win-win situation to me. And they're going to always be producing plastic anyway. I mean, electric cars are made of plastic, for fifth sakes, right? So what do you do when your Tesla's old and you want to get a new one? They go take it to a scrapyard. Well, they're going to get all the metal out, but all that plastic and all that other inorganic crap in there is just going to get thrown out into a landfill or the ocean or some crap. Well, I'm saying, give me that inorganic crap, and I'm going to turn it into fuel. You know what I'm saying? That's what I'm saying, right? How does the burnt carbon smell? It does not smell anything like plastic. It smells like pyrolysis. What can I say? So, your invention completes the recycling process. Yes, it does. That's the exact goal. Complete the recycling process. Absolutely. I mean, you couldn't have said it better than that, my friend. That's exactly what it does. What do you guys reckon? That yoga ball's almost full? Yeah? What do you think? It's nearly full. I remember one time I got the yoga ball so full because I didn't come back in time to change it out. I was afraid it was gonna bust. But what actually happened is, let me tell you guys, the waveguide covers I have on my reactor are actually rupture discs. They're actually rupture discs. So what happened was the yoga ball got super full, super tight, and then one of the waveguide covers broke open, and it just like. It was spewing out. It was spewing out the pyrolysis gas. It smelled horrible. But it didn't blow up. So before this reactor ever blows up, there's like 1, 2, 3, 4. There's like 5 different pressure release valve systems on. Actually 6, because the yoga ball could explode too. So that's great to know that this reactor will not blow up. And another thing I want to say is that this reactor, like, it is always under some type of positive pressure. It's less than 1 psi. Because I have a gauge on there, it never gets up above, it never even gets to 1. But I know it's under positive pressure at all times because it's always like, first of all, it obviously can fill up a yoga ball. That's proof right there. But also, when I open up one of the pressure release valves at any point, it will always like, make that sound. So it's obviously some pressure building up in there. Nice, Gandalf. Yeah, got me good old pipe smoker, mate. So, I mean, like, if we're talking about efficiency, guys, because some people talk about efficiency, that's another way to improve efficiency, to increase the working pressure. You know, if we get this thing up to, like, 10 psi working pressure, I'm not doing that here at my house. That's scary. But the higher the pressure, the more we're simulating what Mother Earth does underground to actual biomass and algae when she makes oil and all that, right? It's under high pressure, high heat, you know? So that's a good way to do it too. Electricity cost in the UK is 27 per kilowatt hour, and diesel is 1.8 per liter. Damn, your electricity cost is kind of high in the UK, I won't lie, mate. For where I'm at, it's 12 cents per kilowatt hour. Diesel is $4.79 per gallon. So it actually is kind of feasible for me in my area to realistically get a gallon of diesel for less than the price of it. Maybe for you, it may not be feasible. Do you only use trash from your household? Do I actively seek trash from others? I have been storing all of my plastic waste the whole time in the construction of this reactor. You know, this reactor took me like 3 months to build, and I have 3 months of plastic stored. But I'm running through those reserves really quickly. So it's going to come to a point soon where I am going to have to start getting trash from some of my neighbors and stuff because, you know, this thing goes through a lot of plastic every day. I looked up the company here in the US that makes gyrotrons, but you're not, yeah, of course I'm not going to like the price. I don't like the price of even buying a water-cooled magnetron. Are the magnetrons separate from the reactor space with glass or a mica sheet? No, not either. The only type of glass you can use is sapphire glass, because all the other types still can't survive the microwaves and the heat. Even borosilicate messes up. And mica cannot survive the pressure, so it ends up just cracking. I have to actually use fiberglass and Teflon. Those two things combined together actually make a good gas-tight seal, but it's not so tight that they will just like hold on if the pressure gets too high. They actually will easily pop off if the pressure gets too high and form like a pressure release valve, a rupture disc. So, 2-in-1, I like it. But if I were to do this industrially, I want to use sapphire glass because it can survive high pressure and high heat. So that way, you know what I'm saying, Because those work, right? Since I'm not working under high pressure. But if I wanted to work under high pressure, those would be annoying because they'd be popping off after just like going up like a couple PSI, right? So, but if I have sapphire glass and I just have a separate big pressure release valve somewhere else, that's the best way to do it, right? And maybe a natural rupture disc on like the feed port or something. I looked, same here, man. Thank you for all of your, yeah, you're welcome, man. Thank you for joining the live stream, Glassmith. Teflon, doesn't it pyrolyze? Teflon only pyrolyzes in the presence of a catalyst. When you just put Teflon in there, nothing happens. Microwaves go right through it. It barely rises even 1 degree. Like, it does not, and it's resistant to oils. It's resistant to everything. But if I were to put Teflon directly in my reactor, it would degrade. But for it to be at the top where the magnetrons come in, it's not in any contact with any carbon, so it doesn't dissolve. It's just like silicone, right? Like if I put silicone right in there, it will degrade. But if I use silicone for the waveguides, nothing happens. The ball is almost full. Teflon sheet. You try high purity fused quartz. Yeah, guess what? High purity fused quartz is expensive as. Yeah, I'm not even gonna say that, but it's expensive. So I didn't try that because I'm scared. I'll pay like $100 for one piece of quartz, like big enough, just to break it. Yeah, I do want to look at zeolite as a catalyst, but guess what? They're expensive, you know. So I need to not only figure out a way I can afford the zeolites, but also a way to recover them. Like, they're not that big of a deal if I can recover them and regenerate them. But I don't even have a way to separate the stuff from carbon, you know? I need to be able to recover the zeolites and regenerate them. If I can't regenerate them, it's a waste of money. That's why I use cheap waste stuff anyway as catalysts now, like kitty litter, lime, or carbon, because that stuff is waste anyway. So it's like, well, if I can't recover it, no big deal, right? You have access to quartz at a good rate. Okay, the diameters. I know them off of my head. If I get a ruler, I'll be able to tell you if I get a ruler. Let me see. Because I got one of the wave guides right here. Yeah, so I got one of the wave guides right here, mate. And look, the so-called glass or whatever we put in there, the Teflon, it goes on this edge here, right? So the diameters I need minimum for the glass, it needs to be, I'll give you inches, all right? So that's what this ruler is in. It needs to be 2.5 inches by, what is that? By 3.5 inches. 2.5 by 3.5 inches. And usually quartz glass at that size is quite expensive. You like that pipe, Antonio? Yes, I like it too. It's a good pipe. You may not be able to donate money. And no worries about donating money, man. Just watch my videos. You know, YouTube is giving me money. I should really advertise this thing as an off-grid solution. I mean, if an off-grid is expecting an overload and the battery is full. Yeah, I mean, the only case this doesn't work on off-load is if you already have a whole bunch of solar panels and crap, and you want to turn something into oil that can run an engine, right? I did that by asking Alibaba suppliers for a free sample of Winked gun. You should pretend to be some business, and you get that sample for free. Oh, that's a good point. Arangel? I don't know how to pronounce your name. I'm sorry. How thick does a Teflon sheet you need to be? Let me just show you how thick it is, because it's literally simple. I'll show you. Listen, so this is a Teflon sheet right here. Really thin, as you see. It's nothing special. Literally, like they use this for baking. Literally. But if you just use this alone, then it has a risk of kind of like blowing off easily, not destroying itself. So I use fiberglass behind this. But this makes a nice airtight, oil-tight, watertight seal. So I mean, but of course, the thicker the better. You know what I'm saying? If I could get a thicker one, I would. But you know, this is all I can find. I have to use consumer level products here. Okay, I can't use some industrial Teflon. You have 3.8 inch plates of borosilicate on hand. I have borosilicate as well. It doesn't work. I already tried it. It cracks, which is weird because you know the borosilicate glass window I have on this reactor never cracked. It's never leaked, never cracked, never given me any issues. But when I have the borosilicate put in front of the waveguide, it just is like extra. Like, dude. And no worries, glass. No worries, no rush, mate. We're sitting back chilling. I'm chilling for sure. I don't know about you. I'm definitely chilling, mate. No worries, my friend. Yeah, it is strange how it cracks, because it can survive the heat. I think that it's just the rate of heat. It's just the rate. You know, when it's right there near the source of the microwave, near the magnetron, it just heats up so quickly. Any plans on making more distillery videos? Yes, sir, Christian. I was just talking about that earlier. I'm running the distiller right now as we speak because I'm going to make a new video on distilling either tomorrow or Monday. We're distilling a 3/4 of a gallon of the pyrolysis oil, because I want to make enough to put it in a car engine. That's the goal. In fact, let me make sure this distiller is still running. Yeah, it is. It is still running. So we're going to do another distillation video soon, and I'm going to be building a new distiller as well eventually. It will take some time, because it's going to be it's going to mimic the industrial distillers, you know. Have you have access to a laser cutting shop who can cut 1/8 or 1/4 Teflon sheet? No fiberglass decomposes under microwaves. It's completely dielectric. The Teflon sheet, Teflon is so soft I just cut it with scissors. So I don't get any laser shop. I don't have access to a laser cutting thing. Everything I built has always been by hand on the reactor and everything. I don't have access to laser, CNC, all that. Oh, you're doing some vacuum distillation. Oh, that is nice. Let me ask you though, because I always wanted to know, like, do you notice a huge difference between the vacuum distillation and just regular? Like, what is the biggest difference you notice? You know what I'm saying? Because I'm wondering if I should make my next distiller vacuum distillation or not, if it's worth all the hassle. You know? Just the fiberglass without... I have a video showing the fiberglass. Which one is it? It's one of the videos I'm... It's a video where I say pressure testing the Mark IV reactor. Just watch that video and you're going to see the fiberglass in there, what I use. It's literally a welding blanket. The welding blankets. That's what it is. Because they're completely dielectric. They don't absorb microwaves. They're heat resistant, chemical resistant, so it's perfect for a consumer scale at what I'm doing, right? If you're doing this at an industrial scale, there's better things to use. But I'm not about to pay the price of the whole freaking reactor for a piece of glass. I'm not doing that. Doesn't make sense to me. So, yeah, just look up the video. You know, I do share pretty much most of what I do. I mean, like, the truth of the matter is, if there was somebody out here that actually wanted to, you could build exactly what I built off the videos I've showed you. You know what I'm saying? If I were me watching my videos, I'd be able to build exactly what I built by watching them. It's just a matter of, no matter who you are, if you're doing it at home, or even at a shop, it's a pain in the ass to build this reactor. It's a pain. It's hell. Because there's so many different things that you have to do. Chemical, electrical, engineering, metal crap. Like, it's so much, you know. And you can build the reactor just fine, but if you don't get the electronic stuff right, it's not going to work, you know. So that's what it is. That's what makes the reactor difficult. The fact that it's just like an amalgamation of everything. You know, not just one thing or the other. So of course, I'm never going to be truly good at any of the one things I do. I'm never going to be truly good at just welding, or just doing the electronics, or just doing the distillation chemical stuff. Because I have to do everything, you know what I'm saying? It's a lot. It really is a lot. But it all ties hand in hand together, and it is beautiful to see how all these different engineerings and sciences come together to really form technology, you know what I'm saying? Like, I really learned how everything is that way. Everything is 5 different types of engineering and sciences coming together, right? All the best things are that way. I think this yoga ball is full now, actually. Yeah, it is full, mate. But now, guess what? I got too many yoga balls full now. But I still have gas being produced from this reactor. So I have to flare it now. I hate flaring it, because it's like a bloody waste. Here's my thing. I have a little, have this little tube here. I'll flare it off of this. This thing is still making gas. I'm not even agitating it right now, mate. Like, look at this. This is straight from the reactor. That is straight from the reactor, guys. That's all. I need to put that on a burner, really, ideally. It's not such a suddy flame. In fact, you know what? I'll just run the distiller with this. Perfect. Because I got the distiller running anyway, off of the stored gas, but I got nothing to do with this gas, so I might as well just run the distiller off of this, right? Let me do that. Real talk. Alright, so I got the distiller running off of the pyrolysis directly off the reactor now. Damn, I put the wrong type of the wrong size nozzle in my burner, so it's really suddy right now. Feeling sud everywhere. Oh my, I can't do it. I gotta go replace the nozzle. Hold up, there's too much black smoke. Too much soot. I'm not no soot slut. Let me fix this mess. Alright, that's better. That's better. That's better. Okay, now my hands are good. Alright, back. I'm gonna wash my hands, yeah? You know what I need to do right now, mates? I need to agitate these blades. I'll show you guys me doing this. I need to flip the camera around so I can actually see where I'm going. Hold up. Where is that button? Here we are. Look. I'm gonna agitate these blades right now. So what I normally do is I like to go in reverse. I'm gonna go reverse. You see it spinning? So I go reverse for like 30 seconds, or like a minute or so, and then I go forward for like 20 seconds. Excuse me. All that damn soot is making me freaking just deep throated a whole bunch of soot from that freaking flame. God damn it. Excuse me. Alright, anyways, I think it's been like a minute now or so. It's been like 30 seconds. I go forward, now you see like, and I got like this 3-step switch for the DC motor, yeah? And now it goes forward. See, it's spinning the other way. And you know, as we do this, the gas production shoots up a lot as these blades spin. You feel me? Oh, my bad, guys. I didn't even see the bloody comments. Because YouTube paused all the comments. So it didn't even look like anybody was saying anything. I was wondering what happened. I was like, where did everybody go? Let me flip this back around. Yeah, like, I don't know why it's... Man, look, here's the weird thing, right? Every time I try to go live on my computer, it was so glitchy. And, like, the Wi-Fi will be cutting in and out and weird crap. So I have to go live on YouTube on my phone. But then this mobile YouTube stuff is so weird. It's cutting the comments in and out. I can't even see what people are saying. So I missed like 5 minutes of you guys typing stuff to me. So I had to read it all. Said Robert Murray Smith has used coal waste to create graphite. And I think it'll be interesting to see if industry waste could be used as a feedstock for a machine. Yeah, that. And also I want to know what type of industry waste can be used as catalyst? You're still in the learning curve of your vacuum distillation, and it's mostly homemade. Ooh. What type of products you get from paper and cardboard? I did a run with paper before, a while back. I think I did get some oil out of it, and I did get, of course, gas. You get gas out of everything. You think it would be possible to build a microwave reactor in such a manner it could work as a coal gasifier? Are you talking about like a microwave reactor that creates the coal and then the coal runs it? What do you mean by that? Your thoughts on that vacuum distillation has its advantages and will likely help you. Glassware may be more advantageous over the stainless steel in your system. Yeah, I would say that too, but I'm not going to buy all this glassware. You know, I have access to tons of pipes, tons of metal for pretty much free. It's called the scrapyard, you know, compared to paying, to pay for, like, I had to pay so much money to have a distillation setup this big, made out of glass. So I'm just going to keep making it out of glass. What's up, Funky Worms? It's an interesting name. Gasified in the presence of oxygen. So you're saying make a gasifier that runs off of microwaves. I think that could work. Hook it up to an oven. Do you have anything to cook? I have nothing to cook with the gas but pyrolysis oil. Oh, you say I have the perfect opportunity to see how long the gas production will last after I shut down the transformers. You guys want me to like turn off a couple of the magnetrons, see how long it stays on. I mean, you can gasify plastics, but it's going to make a bunch of Brexit things in the air. You must bust the crust. What? What are you saying, bro? Can plastic to gas transformation with microwaves be economically viable with better design? I see that you use more energy than you get. I know this is R&D. Do you think you could do better? Yes, of course, you can always do better. I mean, I built this in my freaking backyard with the most inaccurate measurements and crap possible. This isn't even fabricated, like, for real. I didn't even weld this thing that good either. Like, I literally, like, this is, like, as crude as you can get. So the fact that I can even say that I can get, like, over 80% of the energy that I put in back out with the products with this type of engineering, this homemade DIY level crap Home Depot reactor, I think that's a really good sign, because this is far. I don't even have most of it insulated, you know what I'm saying? In fact, the insulation I'm using isn't even all that good, you know? There's just so many ways that I could easily make this so much better. You check the compressor oil for contamination? Nope, but I know it is contaminated. I just don't care. I wish you would have a public email. I am on Discord and I have a public email. I literally have both of those things, mate. They're all in the description of my videos. Every single one of them. Yeah. You can just send me an email. No, I don't respond right away because I usually am doing things, but I'll respond eventually. Guarantee that much. Respond eventually, mate. You know, I'll give it a reference. My Mark II reactor. I started uploading videos about it beginning of this year, literally the first day of this year. And when I started making videos about it, that was pretty much when I first built it. I used that reactor for, what was it, 5 or 6 months before it was really at a point of like, okay, this is the best this reactor can get, so I need to build another one. I just finally built and got this reactor running, up and running now. We're not even a month in. So we have at least a half a year of improvements to do to this thing, if not more, to make it even more better, even more efficient. I mean, like, I am not at all worried about that. Damn it, I clogged my freaking pipe, dude. So what's in the pipe? I have sage and rosemary in there, because I grow sage and rosemary in my garden. And you know, they actually taste kind of good, I won't lie. Yeah, I tried waste engine oil. It actually makes quite a bit of diesel. Talking about minimizing the amount of reactors, not really microwave gasification of coal, just regular O2 gasification run inside of a microwave reactor. What do you mean by inside of it? How can you do a gasification inside of a airtight reactor? Do I put the waste compressor oil back into the reactor for disposal? Yeah, I mean, any type of waste oil I get, I put in the reactor. Whether it's waste food oil, any type of oil I put in there. All of my waste, all of my trash goes into this reactor. All of it. I have 0 lab waste. Even the dirtiest stuff can all go in there, as long as it's organic, and not like... I mean, as long as it's not like fluorines and chlorines and all that crap. But even then, I have filters, I have catalysts that react with stuff, so, you know... All I lack is the proper tools to measure what I'm getting out. Well, I mean, like, the truth of the matter is concept of everything. If this reactor was truly industrial and continuous, I would never be depressurizing it. It'll be continuous. It'll keep going. You know? Dude, I can't unclog my freaking pipe. It's pissing me off. I'm trying to have a good smoke here, mate. Thing got clogged with some type of tar. It's crazy. Almost there. Kinda have to like burn it out. Like, burn whatever's in there out. They got caught in the filter. Yeah, you said yes. So you, I mean, like, I'm trying to figure out what you're saying. Are you trying to suggest, to just build a gasifier for the coal? Yeah, a fume hood would definitely be better. Any type of exhaust system. When I empty out that carbon, it just makes a freaking cloud of dust. It gets everywhere. I need something to do something about. Maybe I could just even hook up a shop vac just nearby. Just have it like nearly output. Because that stuff, I never thought it would put out that much dust, if I'm being honest with you. And I've never had that issue with any other reactor. Because all of my other reactors sucked nuts. It didn't work good, but this one works. So it makes that dusty carbon. It falls to the ground really quickly after it comes up. But that's annoying too, because now the whole ground is just so dirty. And you know, that type of stuff gets everywhere. It stains shoes forever. It's not good. Suggesting a mixed reactor capable of microwave and... But what are you talking about? Because you're talking about make a mixed reactor capable of microwave and standard gasification. But this reactor doesn't do gasification to begin with. It just does microwave pyrolysis. So you can't really turn... Well, I mean, you could turn a pyrolysis reactor into a gasifier with a valve for air to shoot in, I guess you could say. Like if you had a valve that you can shoot compressed air in or something, I guess you could. But like, you are talking about two different types of reactors here. A gasifier and a pyrolysis reactor are not... They don't really go hand in hand, really. They're kind of like almost the exact opposite. But could you do gasification in a pyrolysis reactor? Yes, you could, I guess, if that's what you're trying to say. Yeah, you're right. It is a step in gasification. You're right. In downdraft gasification. The highest weight reduction I got was 6 pounds. I put 23 pounds of carbon in there, and I got 16 pounds out. So 6 pounds. I'm also going to weigh the gas too in the yoga balls eventually. In like the next video or whatever. Oh shoot, I need to really be capturing this gas though for the video. I got packing peanuts in the reactor right now. Shit, god damn it. If only I didn't have all my balls full. All my freaking balls full. I need my balls sucked dry because they're all full right now. Damn, that's crazy. Because now in the video, even though we probably got like 3 yoga balls full of gas from the packing peanuts, I only have 2 yoga balls to show. Because I'm flaring the rest of it to this distiller. Yeah, I do have a garden. I do not fertilize it with the carbon yet because I want to make sure I know what's in the carbon, you know? I want to make sure it's not full of microplastics or heavy metals. Yeah, I did answer it already. But you know, it's no big deal. I repeat myself a lot anyway. Yeah, I gotta work it again, mate. I got it unclogged. Good, good. Excellent. Yeah, you know what? The sage has a good flavor. It has like almost like like how mint has like that kind of like coolness about it. That sage has the same thing. Some broadleaf sage. Rosemary. I could use emergency water storage bladders. Oh, that's a good idea. I don't have any measurements of the temperature inside the greenhouse, but the greenhouse does get hotter because those fans on the magnetrons are blowing the hot air off the magnetrons into the air. So the greenhouse does rise in temperature when I run this reactor. So, I mean, that's why I wanted to water cool the magnetrons as well. So then, all of the heat energy we have can be stored in water and used for other things. Either now or later, like almost like a battery. So at an industrial scale, everything will be water cooled, everything. Without a doubt. I tried to water cool the magnetrons, tried to make my own little water cooler. Didn't work. What I might try next is I might try to make like a little container for them, fill it up with oil, water cool that oil, just like they do for the Transformers. I might try that. Might try that. See if that works. I mean, especially now, because like, it is nearing winter. It's starting to get colder around here. It will be useful to have some hot water every time I run this thing. How is the fire safety of your lab? I have multiple fire extinguishers. I don't keep flammable things around, anything flammable. I mean, like, that's... obviously, I have giant yoga balls full of freaking flammable gas, so it's not very safe. But you know, I'm not stupid. I use common sense, you know? I'm never gonna put freaking pyrolysis oil, flammable pyrolysis oil, near, like, something I know is, like, near the output flame of the reactor. So, you know what I'm saying? I use common sense. And then, like I said, I do have multiple fire extinguishers. I actually had to use one of my fire extinguishers last week running this distiller. The whole distiller caught on fire because there was a leak in it. And there was a huge fire. I had to shoot it for like a good 20 seconds before the fire went out. But I need to recharge that one. But I have a backup fire extinguisher just in case if I ever have one that like doesn't work. I have a backup. I need to get a backup for the backup. I would love to use inverter-driven magnetrons, but I'm not good at all that PWM power crap. And I have the inverter boards, but I don't know how to set them up to run them. Because you have to do some weird stuff, which I don't know how to do. I'm not good at all that type of stuff. I'm really good at tangible, physical things. The moment we start going into all this little freaking Python crap, PWM stuff, it's harder for me to understand. So, but yeah, inverter microwaves are the best thing, magnetrons, because then we can like directly power control them and all that type of stuff. So I mean, yeah, in big industry or at the next scale of this, there definitely is another must as well. We may not even have to oil cool the inverter boards, you know, or maybe we may only need to oil cool them. We don't need to water cool the oil that they're in. But yes, I have done research into them. I'm interested in them. It's just that I'm not smart enough to do that right now, you know? I gotta broaden my intelligence capacity. Need to smoke some more rosemary. Then maybe I could do that inverter stuff. I mean, I literally have the inverter board in my little freaking shed here, right? I literally have it. Because I ordered it a while ago. Yeah, the inverter boards, surely they're a lot easier to cool off because they don't have any the big capacitors and all that stuff anyway. So yeah, we do want to do that. And also another thing, I know that they make some big microwave power supplies that like the power supply alone. Like one of these power supplies, right? Like one cord goes to one magnetron. That's 1 kilowatt. Well, not 1 kilowatt, but what is it? Like 2,000 watts to power one magnetron. Well, they make some where the one output alone is 5,000 watts. So almost the output of all three of these here just come from one. So like, you know what I'm saying? When building, do you do calculations? Or is stuff more trial and error and elbow grease? Definitely a lot more trial and error because every time I try to do calculations, I piss myself off because like when I built this reactor, right? I try to just make something exactly 4 inches. I go to cut it by hand, it comes out 3.91 inches. I get pissed off because I'm like, if I'm gonna spend so much time measuring all this crap and I can't even cut it right, then it kind of sucks. I mean, I still measure it anyway, but it's like when it all comes together, nothing fits up perfectly. Nothing is exactly how I want it because I lack the tools to accurately cut things, to accurately weld things. I just do the best I can do, you know. But if it were up to me, I would obviously want everything to be calculated and all that. I am doing better with that now, even, you know, when I weigh all this stuff now. That was a suggestion of many of the scientific people. Because for me personally, I'm always more of just like a type of, I'm just going to make it work. I'm going to get it done, no matter what. Like, whether we know the numbers or not, I'm going to get it done. Whether we know the exact weight of 1 kilogram of plastic to how much oil, I'm going to get enough oil to put in the car, and we're going to run a car off of plastic that is diesel, right? Diesel meant from plastic regardless, right? That's how I am, right? But obviously, for any type of scale up or replication, we're going to need these numbers. So that's why when I do eventually go to patent this thing, it's going to be hell for me because I'll have to pretty much rebuild it from scratch with actual real numbers and stuff. But hopefully by then, I have enough money where I can like just hire a CNC shop to just make everything for me and I just weld it all together or something, right? You know, hopefully. But I am being a little bit wishful on that. I mean, all I need is like one good sponsorship and I'm good. One good sponsorship from YouTube. That's all I need. Freaking Red Shadow Legends come along, right? I'm good. Or just more views. That's it. You know, if my videos, if I was getting like 10,000 views per video, all my videos, I probably would make more money doing this than I do working at my job. My job only pays me once a month, and it's only like around $1,000 a month. I ain't getting paid squat, right? So honestly, I do need to just like get to a point where like I get more views on YouTube. So I stop working there, spend more time on YouTube, where I'm making more money anyway, right? Upload more TikToks than YouTube. Well, TikTok, every time I upload on freaking TikTok, they've just suppressed my stuff. They don't show it. They show it to like 1/800th of my followers. So I mean, like, I'm still gonna upload TikToks, but all the TikToks I upload from now on are just gonna be spin-offs of my YouTube videos. I'm never gonna upload anything specialized to TikTok because they don't even show it to my followers half the time. I'm not making new accounts either. I'm not doing all that bull crap. I don't got time for that. I just keep all that energy it could be spent on TikTok. That short-term crap I just spending on YouTube, right? I mean, because most people on TikTok, they just come and go anyway, right? And I know that because obviously, if I had even half as many followers on TikTok that I do on, if I had even half as many followers on YouTube that I do on TikTok, you know, I'd be in a much better place, right? But no, it's not how it is. Yeah, it is a lottery in some sense, but it really shouldn't be because I'm doing something so niche and so specialized that so many people want to see, you know? So it really shouldn't be some type of like lottery, like, oh, if only I can get a big video on YouTube. It should be a thing where it's like, it's just a matter of time when I will. And that's why I'm uploading no matter what. You know, I'll keep uploading regardless. I can get 200 views, I can get 2 views. I'll keep uploading. Because you know what? I know when I was trying to build this reactor, I was looking for videos. I couldn't find anything. Especially on microwave reactors, there was nothing out there. So I don't want somebody to come along that wants to do what I'm doing, and they can't find anything, you know? So at the end of the day, if you look up microwave pyrolysis, you're gonna find me. No matter what YouTube does, no matter whether they suppress me or not, you're gonna find me. So if you're interested in this, you're gonna find one of the best resources for it online, which are my videos. So it'll be able to help you if you want to build one, right? So you won't be in the same position I was in, where I do so much research and really just come up with a lot of stuff on my own because there wasn't anything around me talking about how they work and how you put a microwave pyrolysis reactor together, you know? So that's really one of my main motivations. Maybe a local news coverage. Yeah, that's true. That's true. There's a lot of different ways. But you know, I'm just going to take it how it is because the truth of the matter is, if I were to blow up overnight, I really wouldn't be ready for all the opportunities because I don't even have the reactor the best it could be, right? Or like, I don't even have the reactor continuous yet, or how I truly want it. So like, it is what it is. I just keep doing what I do. I'll just keep working at my job until I eventually can just make this my full-time job. But you know, just take it one day at a time. You know, at the end of the day, I'm doing the reactor because I want to do the reactor, and I upload because I want to upload. It's that simple. Is it on right now? Yeah, it's on right now. Yeah, you know, the reactor is actually kind of scarily quiet. It's just the fans that you hear. But when the fans are off, which I would never do because it'll kill the magnetrons, but when it's just the magnetrons and just the water pump running, it literally is so quiet. Like, there's no sounds. It's kind of scary because it's like, it's quiet. But if you were to touch one of those magnetrons, you're done. You're dead. Even though it's so quiet. Yeah, my video quality, you say it got better, it gets better over time. I would say, you know, as of late, it has been worse than before, just because I'm kind of trying to do a new format. I'm trying to do more quantity of videos. I don't want to decrease the quality, but you know, that comes with when you increase the quantity. It's just like when you increase the horsepower, and when you increase the speed of a motor, you get less torque. It's just how nature works, right? But I want to upload a lot more videos. Well, at least with decent quality though, you know. So I want to be uploading like at least like 3 to 4 videos a week minimum. Because the more videos I upload, the more chance that somebody just going to YouTube might just see it, right? So I'm not trying to make my videos like horrible quality, but I'm also not trying to make them so high quality that I'm uploading like once a month or even once a week. I gotta upload more consistently than that. And on top of that, views help too. The more videos I upload, the more views I get, which is the more monetization money I get. You know what I'm saying? Even if the videos individually don't get that many views, when you upload so many, they all come together, and you actually, it doesn't start to add up. Did I upgrade my distillery? No, it's not more passive. It just is that the distillery takes like 10 hours, and it's only been running for 2. That's all it is. Like, when I showed in the video, I speed it up, I time lapse it, but the thing literally takes 8 to 10 hours to do, to get all the stuff out. Like, it's a long process. That's why I will be building a new one, which is more passive. More akin to the ones in the oil refineries. If there was an option to opt out for paying for trash, you've already... Yeah, that's true. So I don't have to pay for trash services or recycling services, I just do it myself. You think Big Oil is keeping a close eye on you? I don't know. Honestly, I don't know. I don't know. I think that there definitely is somebody looking at me on TikTok, though, for sure. Because sometimes it's not a coincidence. Sometimes it's not a coincidence. On there. How sometimes, like, I just have a video do well, and then the next video will get, like literally almost no views. Despite me having over 100,000 followers, you know what I'm saying? So I think somebody on TikTok is looking at me, and I had some of my videos on TikTok get taken down, or, like, flagged as dangerous for nothing, you know what I'm saying? So I feel like maybe on there it is. On YouTube, maybe not. I think maybe on YouTube it's just the algorithm on YouTube is trash. Yeah, I will do that. That's the first thing beyond anything in this reactor. Plastic waste being used for something better. Plastic waste being actually recycled. That's like the biggest thing about it before anything else. All this other energy recovery stuff is just an addition. Because nobody is over here asking all these questions about energy out when we're talking about mechanical recycling or recycling steel, scrap metal. I'm doing the same thing, just with plastic. But we're just getting energy out of it. And since I say we're getting energy out, everybody then wants to be like, well, this won't work just because it's not more than what you put in. When really that should never have been the focus to begin with. The focus should have been, we're recycling. Well, you are a great soul. I appreciate you for all your work. Thank you, Insightful Ali. Wait, that's not your name. Insightful A 1.0. Thank you, brother. Thank you for tuning into the live stream, my friend. Thank you all for being here. Matter of fact, yeah, I want to go live stream pretty much like every weekend. You know, just to talk to you guys, really. I don't care if there's one person in here or 10 people in here. I'll go live anyway. I'll just talk to myself if I have to. I was doing that for the first, like, 5 minutes of the live stream anyway. Cosmic forces will ensure you're able to enjoy the fruits of your labor. Namaste. One love, fam. Yes, one love to you too, brother. I'll smoke to that one. Definitely keep up with you. Thank you, Rose Wolf. Thank you. You're considering studying petroleum engineering, so you find it extremely interesting. We went with nautical science instead. Oh, that's interesting. Nautical science. I mean, what you learn in nautical science is that, I know, like, is that what you learn about the, it's not marine life, right, is it? Like, you know what I'm saying? Or is it, like, more of, like, the sea, and how the sea works, the ocean and all that? Or boats? I'm working on getting some things to create an orgone generator. Yes. Yes, my friends. Why I use argon instead of nitrogen? Because I just had an argon bottle for welding, and I don't have a nitrogen bottle, and I'm not gonna pay $200 for a nitrogen bottle when I already have an argon bottle. It does the same thing. Argon is, nitrogen is cheaper, I think, but I'm just gonna use what I have. Yes, LeBron James, I'm going to run a car off of this fuel very soon. I'm letting everybody know that now. Now, I don't know how big it's going to get. Who knows what they do to my stuff now. But that will be a huge achievement. We're going to run a diesel car very, very soon. Okay? It'll never be as energy efficient as just burning the plastic. But that's the cost for being environmental. Exactly. Because people do say that all the time. They're like, you might as well just burn the plastic. No, you might not as well just burn the plastic. And let me tell you, if you burn the plastic, can you store that energy? Not really. Not really, my friend. But if we turn it into oil, we can burn that oil now. We can burn it 3 years later. You know? There is an advantage to making it storable fuel like what we're doing. You know? There is an advantage. Boats, navigation, and leadership on ship. Oh, some more. Okay. Interesting. I didn't know they even taught that in college. Interesting. That's actually really cool. The maritime stuff. You will get it all, brother. Know it. Yes. Hey, we're all a part of this. We're all a part of this. My brothers and sisters from all around the world. I mean, of course it's cheaper to just burn it and to have filters. But, let me ask though, if you're still making a profit, if this is more expensive than waste incinerator, if I'm still making a profit, I'm just making less of a profit. But I'm still making a profit. You know how much debt the Tesla's in? You know how much debt that Ford is in? They're not really making profits anymore. Subsidizing, all these farmers are being subsidized by the government, the big daddy government. So if I'm making a profit at all, in any capacity, I'm already way better than almost everybody else. I'm way better than Tesla if I'm making a profit. I agree with you, China Unhinged. I completely agree with you. Because you know what? CO2 does have uses. CO2 at least is something that nature can use. Trees use it to grow. If we are turning plastic into CO2 and we're planting more trees, because the trees can actually grow because the ground isn't contaminated with freaking plastic bottles, then I think that's better than the plastic being in the ocean and the freaking ground. Or heck, the algae in the ocean. Algae in the ocean can't grow because there's so much freaking plastic all over the place covering up the surface of it. Well, if we take all that plastic out, turn it into CO2, now the algae's growing again. The algae eats up that CO2. At least nature can do something with CO2. So for people to even come to me and tell me that we're better off just leaving the plastic in the ocean, that's nonsense to me. People that actually say that. People are like, you're better off just leaving it in the freaking ocean. Are you kidding me? Really? We're better off keeping it in the ocean than recycling it, truly recycling it into fuel. That is nonsense. Remember us when you make it big. I don't have to remember anybody, because we're all going to still be here. We're all still going to be chilling out on Livestream. Same difference. What are my thoughts on Team C's? I think it's the same issue with every other thing. You're getting the plastic out the ocean, but plastic is still getting put in there, and you're just putting it in a landfill. And maybe if Team C's partners up with me, they'll make more sense. We're getting it out the ocean, now we're making fuel out of it. You know? I'm not saying that what they're doing is bad, but all I'm saying is what they're doing is it's not really not going to progress this whole issue. I won't lie. It's not really getting anywhere, if I'm being real with you. Because just as much plastic is still being dumped in the ocean, you'll be in that cycle forever. Big companies dumping plastic in, you're taking it out. They're dumping it in at a higher rate than you can take it out. You know what's better? Having a cheaper option, or an option of same value to these companies. You pay them for them to give you their plastic or some crap like that. Who knows? And you turn their plastic into fuel. That's better than me. Yeah, CO2 batteries. There's CO2 capture. I mean, I think the best CO2 thing. I think the best thing you can do with CO2 is grow trees. I think that's the best thing. I think that is like, there's nothing better you could do with it than that, because trees benefit everything for so long. Plastic is already the energy store, just less accessible. Yeah, that's true. You know, plastic on its own has more energy than gasoline and diesel combined. 21 companies produce 80%. That is stupid, man. That is crazy. That is mad. Capitalism 101. That is 21 companies, 80% of waste. What? What if you were to buy plastic granulates? I don't know where to buy that. I'd rather just buy or make a granulator and do it myself. You know? That'd be like me paying for shredded plastic. Let me just buy a shredder and pay for it myself. Because the cost of buying that stuff will easily outweigh how much it'll cost to just build it yourself eventually. You know? Yes, sir, Christian. I do grow my own sage. It's one of my healthiest plants in my garden. One of my favorites. I've had the same sage plant for 4 years now, I think. 4 years. And I am definitely enjoying its harvest. I'm definitely reaping its harvest. And you know what? When I put the kilowatt meter on the plastic shredder, it consumed a lot less electricity than I thought it would. A lot less. It consumed 0.06 kilowatt hours for me to shred like a whole bag of plastic. So that's good to see, because industrially, obviously, we want to save as much energy as possible on all the steps, as much electricity. So that's good to see that it doesn't consume that much. Of course, the reactor is the biggest consumer of energy. And also, another thing that was good to see was how little energy the motor consumes. Now, of course, I don't have the motor running the whole time, but when I do have it running, it literally only consumes like 1,000 watts or something. Not even 1,000. It doesn't consume much, is the point I'm trying to say. Of course, it's the microwaves that consume the most. They consume the most energy, the most electricity. But I feel like there's some things we could do with that. You know, especially with all the heat they produce, we can do things with that. Now, I was thinking, you know, if this was an industrial plant, we could easily have all the heat that they make heat up the water for the whole plant. You know? Easily. They make a lot of heat. Yeah, that would be good. If I could use the excess heat to granulate, that would be good. That's the type of thing we need to do. Because that's kind of like what I do now, where I use the excess gas to distill the oil. Like, that's true efficiency, when you use everything you have, everything, to do something. Got my freaking thing clogged again. You bellend, you bloke. Freaking pipe. Clogged again, dude. Are you kidding me? This is the best way to unclog it. Just heat it up. And you blow through it. Got some tars in here. Why is rosemary and sage making tar? What the hell is going on? You can use it to run a Stirling engine. Yeah, that's true. That's true. It's a lot of things. So I mean, heat. You can do anything with heat. These are industrial scales ideas you got to come up with. A bunch of these processes in theory. Yeah, it is far from practice, you're right. But it's the idea, you know. Hey, think about it like this. And I think you remember this concept of everything because you're an OG, you've been around for a long time. Do you remember when I had that video way back, like 7 months ago, of me with my Mark II reactor hooking up a blender blade in there to agitate the plastic around? You remember that? And look at where we're at now, right? So in that moment, that was just theory. Far from practice. It was horrible. I never even used the agitator because it didn't work. But now, 6-7 months later, we actually have it working in practice. So it takes time, but the idea is where it always starts. You need the idea first. So absolutely, brainstorming is the key. I mean, I don't even have the videos on my YouTube, but when I first started to experiment with microwaves, I literally had I took a microwave, like a literal microwave, put plastic in there, inside of a glass jar, with a microwave absorber, and was having the plastic come out of a little tube out the top, the syngas or whatever. Like, literally, it's always the idea how it starts. You never can look at it like, well, it's going to be the best it is from the beginning, because it never will. But the idea will get you there, you know? That's why I'm glad I recorded everything. And I'll upload all that stuff on YouTube one of these days. But I guess it's cool to, like, look back and see, like, wow. I always knew that it would have to get to a point like this, you know? But, like, I knew how long it would take to get there because there was so much understanding and learning I had to do along the way, right? And I'm glad it took so long because, you know, especially after Mark III exploded, I learned so much, you know, so much. And the explosion, it taught me a lot more about, you know, how this is almost like a pressure vessel. There's a lot more than just a reactor. We're just doing reactions within it. We're doing reactions within a pressure vessel that runs off of microwaves, you know? Yeah, right, exactly. So, and that's the point. We want people to be able to hear these ideas and put them into practice without me or you, because, you know, if this whole idea, if this whole project is based off just me, then what happens when I'm done? What happens when I die? What happens if I just quit? Then this idea is done? No. We want other people to always be working on this. You know, we want this to be a thing. Because, I mean, the world needs this, right? The world absolutely needs this. So, it can't just be based off of me. It can't just be based off of you. It needs to be like a group, community thing at all times. That's why I share everything. That's why if you ask me how it works, I'm going to tell you. Even though all the people around me, all my family, everybody, every business person I talk to tells me I don't need to tell people stuff. I don't need to share as much because people are going to try to steal what I made and patent it or whatever from me. I still tell people how I built it anyway, because I know 99% of people just want to build it or know how it works just to know how it works or just to build it for themselves. You know what I'm saying? So I'm not gonna not share the information just because there's those 1% of people that want to actually steal something. I mean, like, they can go ahead and try and they'll realize how hard it is to actually, when you actually go to build this, you know, it's a lot harder than it looks. But then I can never make it sound. It's a lot harder. Yeah, that's true. You won't be able to operate it without certification. In fact, I'm sure it's straight up illegal that I have this in my backyard. Let alone the freaking refinery. That's definitely illegal. But I don't... It's pretty much like a whiskey still, right? But it really is not really illegal until I start selling stuff out of it, right? It's way more than 1%. Yeah, I'm sure it is. I don't really care, though. Like I said, they go ahead, try. It's not gonna be so easy. I mean, because I will tell you. I would say this reactor was 70% physical labor, 30%... No, I said that backwards. 30% physical labor, 70% mental labor. Before I ever built anything, I could see it all in my head. I could see the ideas, I could put them together. I saw the auger blades in my head spinning the plastic turning into carbon, me opening up the door, and the carbon falling out of the reactor. I saw that months ago before I ever even had a video on YouTube. Before I ever even had the reactor done. I saw it in my head. Before I ever had the reactor getting really hot, I had a dream of the reactor getting up to 800 degrees Fahrenheit. And then the next week I got it up to 800 degrees Fahrenheit, which is like 440 C. So I mean, people can go ahead and physically make what I made. But you're never going to be ahead of me because I see it in my head before it's even physically there. You know what I'm saying? So they can take what I have shown on YouTube, but they don't even know what I'm thinking about in my head, what I see in my head for the future. So, I mean, you can take this. Go ahead, take this model. This is the batch version. The continuous version is going to be a whole other thing. So I'm not going to live in fear because of that. I'm not going to be scared. Somebody's taking what I have. I mean, they do what they want. The truth of the matter is, I've posted too much anyway online. If there was somebody like me with the proper resources, like somebody with my mind that can see stuff and the proper resources, they would have been able to build this anyway. You know what I'm saying? Because think about it, I built this off of not having crap posted about it online. So if it was me back in the past, like a year ago, looking at microwave pyrolysis, and I came across my channel, I would have been able to build this immediately. Like I give so much. I give so much. What are the benefits of fracking? I mean, it works well. It's easy. Less energy consumption. But of course, it does do quite a bit of damage to the environment. But that's how things are in life, right? It tends to be the easy things mess stuff up. It's the hard things that are the right way to go about it. And at the end of the day, you end up having to go to the hard things anyway. Because we wanted to do all this stuff that was messing up the environment for so long anyway. But now that we're having all these issues, we have to go back and do the right things at the end of the day anyway. Because now we're in trouble, right? So it's like you might as well just do what is right, not the shortcut from the get. That's exactly what I'm doing. I'm not doing the shortcut. You know what, guys? If I didn't want to do the shortcut, I would have already accepted these investors, and I would have already had to go silent on YouTube and freaking be in some type of warehouse building this thing. They're taking like 70% of everything that comes with it, all the monetary value and all that, right? But I was like, you know what? I'm not gonna do that because I'm gonna do it this way. I'm gonna do it this way where it's still a community thing. You know, I keep it real. You know, because I don't even have this thing done. And people want me in all different types of countries, coming around here, coming around there. Build it here. We'll pay for their property. We'll pay for you to stay here. You know, all that type of stuff. But for me, I'm like, wait, it's not time yet. You know what I'm saying? I'll take it slower. And do it the right way. Because imagine if I went to another country and I built Mark III and it blew up. Killed somebody. Would have had to end up coming back here to build this anyway. So ain't no rush, baby. We're taking it slow. Ooh, peppermint is good in there too. And garden grown peppermint. You know what? A lot of that peppermint flavor actually comes over a lot more than I thought would. That cool crispiness to it. Well, guys, it was cool hanging out with you. You know what I'm gonna do? I'm gonna try to go live on TikTok for a little bit if anybody shows up. If not, I'll just go ahead and put it up for the day. But it was cool hanging out with you guys on YouTube. What's up, Harry Shepherd? Oh, you just stopped by. Hey, you got any questions, Harry Shepherd? Because I'll take some time to answer if you do. Yeah, you can get the metals out of plastic. There's not much metals in plastic, but there's some heavy metals like mercury and stuff. And when you put them in here, the end of it, you get them out. So, I mean, with vacuum distillation, let me ask you, Glass, the output of it, right? Where the oil is collected or whatever is coming out, is that under a vacuum as well? Yeah, sponsorship is not really a financial strategy in the long run. You're right. You're right. But I just need to get somewhere. I just need to freaking. I need to just stop. I want to be able to actually just make this my full-time job legit. Like, really. You know? And I want to be able to actually afford a lot of the things. Like, I'm kind of stuck at how far I can go because I can't afford a lot of the parts I really want. I have to really make my own ghetto versions. You know what I'm saying? Like, I had to build my own heat sink for the oil that is for the water to water cool the oil that transformers were in because I couldn't afford to buy a heat sink, right? So like even though it works, it's kind of like, well, it could work even better if I just bought a heat sink, right? I have to kind of like I have to go Mad Max on everything, you know. It's not a bad thing. I'm a resourceful person. I'm gonna make it work, but it's like this project will go so much easier on everything if I could just buy some things. You know what I'm saying? But obviously, when you're doing things that are this niche and this specific, even the stupid things like quartz glass cost $100 frickin' for one piece. You know? I gotta make my own little ghetto trifecta of Teflon and fiberglass and crap put together. But it works, so that's all that matters. Okay, so the whole system's under vacuum. Okay, that makes sense. Huh. So let me ask you then. This. I always wonder this about the vacuum distillation. If it's always under vacuum, what stops? Like when you do your distillation, how does the stuff separate? Because the vacuum is like sucking everything to the very end. So like, won't that like just cause all the vapors to just mix together instead of separating? You know what I'm saying? Because I always wondered that. I did always wonder how that works. How the separation works. I know you do save energy on vacuum distillation because it doesn't need to be as hot. So, that, you know, if this next one I built needs to be a vacuum distillation plant, I'll make it vacuum distillation. I just know it's a whole other mindset of welding where you know you gotta weld vacuum tight. I'm happy for you, man. Thank you, the ultimate Blue Mac Kazaz. Thank you for stopping by. And I'm so happy that we have people, you know, I have people watching what I do. It means a lot. I think I have what it takes to make this full time. I agree. Just all it takes is just a little bit of the right cards at the right point. I have faith. For the end of this year. I have faith. I don't even have a doubt in my mind. I'll be set. Especially with me uploading like I've been doing. I'm gonna make it. I don't even doubt it. It's inevitable. I do it. It's just too many good things. I'm doing something the world wants to see. I'm doing it in an entertaining way. It's happening. So it's based off the boiling point. You're right, there is a greater thermal distance. Oh my goodness. Smart chemist you are. You're right. Thermal distance is greater. So do you get better separation then? Like in total? Because for column distillations, right? The fractional distillations they use in oil refineries is kind of done like automatically, like passively. So I wonder if that's even possible to have vacuum. Got a lot of research to do, clearly. Okay. Yeah, because you know what? when I'm trying to separate my diesel and kerosene fractions, it's kind of hard because they're so similar. So, you know what? Here's what I'll do. The next one I build, I'll make it to where, like, I can hook up a vacuum pump to it. You know? That's what I'll do. So that way it doesn't have to be vacuum distilled for it to work. But if I don't want it to be vacuum, or I mean if I do want it to be vacuum, then we're good. Then don't fall into that self-admiration trap. What do you mean? Self-admiration. What does that mean? You admire yourself? The chemical processes are similar. I mean, I'm sure the chemical processes for distilling are kind of similar no matter what, right? See, I would do it under vacuum. I would have my reactor under vacuum, but I don't trust my welds. Because when I was building this reactor, I was welding on 110 volts. So even though I did get full penetrating welds, I just don't like... And it was my first time welding stainless steel as well. I don't trust that I have no pinholes at no points. Because if I have it under vacuum and there's pinholes and it's sucking in oxygen, I'm making a bomb. I'm making the Tsar Bomba. I'm about to take out this whole continent of America. You know? What I want to do is I want to build a small reactor. This same design. Really small. And I want it to be like perfectly airtight so I can run it under a vacuum for tests. And I want to do a test where I do run it under vacuum and I can guarantee it's safe, and it'll be smaller as well, so like it doesn't blow up horribly if it did blow up, you know. I know like vacuum tight and airtight and pressure tight are all kind of different, right? And then there's like extreme vacuum, like ultra vacuum and crap. You know, obviously I'll just be putting a light vacuum on a reactor here. I don't even have a strong enough vacuum pump. But, you know, I still don't really want to risk that just because it is kind of scary to think it could potentially suck in air. It would kind of just make it a gasifier though, wouldn't it? Say, it's nearing narcissism type of stuff. Man, I guess you see it that way. You know, me personally, I just see it as, you know, like, let me tell you what happened, right? I remember, I built this Mark IV. I came back, like after Mark III had exploded. I came back to YouTube, TikTok after Mark IV. And like, at that point, there was no, I was getting no views or anything, right? And I kind of was expecting it. So it kind of messed me up mentally, because I was like, dang. I did all this work and nobody's been watching it. Because YouTube was barely like showing myself to any of my subscribers. It's like, what the heck? So I was kind of coming from the perspective of, like, I'm doing this for people to watch it. Like, I'm doing this for, like, now. But I kind of changed my perspective to, like, I'm doing this so that way, not only for now, but for the future. You know, to where it's like, even if, like, right now I get no views for, like, a whole next year, maybe one day somebody will come along, find my videos, be able to make something of their own because of, like, the research I've been doing and posting. You know what I'm saying? That's kind of the perspective I come at it from now. So it's like not really as much of like, I would even say confidence. It's more of just like, I just see it as, I'm doing this completely for me now, you know? Not really for the views or not for anybody to see. It's just more of like, I'm just doing it. I'm uploading it because I want to share it with the world. And I'm doing this because I want my plastic to be recycled in a true way, you know? And I feel like it's just kind of inevitable for eventually, for you know, for it to catch up eventually, you know? That's all it is. You can pump a vacuum seal. Yeah, you're right, you're right. That is a good point. That is probably the best way I could do it. Seal it off for a couple days, see if it can hold a vacuum. That's a good way to do it. That is a great suggestion, actually. See, and that's so obvious. It's like, why did that come to my head right away? You know, I feel like sometimes your own perspective is so narrow That's why you need other people. You know, it'll be amazing if I had somebody else, like in my neighborhood or something, from my school, that like was just as passionate about this as me. We're both working together. Yeah, anyways, guys, good seeing you. I'm gonna go live on TikTok for a little bit, see if anybody joins. If not, like I said, I'll just go ahead and get off. But it was good seeing you all. Peace out, mates. With metals welding, you can get perfect seals. With glass apparatus, the welds can be complete. I believe you also has a video where they show glassware. True, true. That's true, Glassmith. Well, take care, you guys. Peace out.